So let's talk through some of the key points about graphs of polynomials and how you can start to sketch what that graph is going to look like by just looking at the equation. So first off, if you look at all 8 of my graphs, you can see that the domain is always going to be all real numbers. For each of these graphs, they extend on and on forever in both directions on the x-axis. So on and on forever to the right, on and on forever to the left. However, the range is only sometimes going to be all real numbers. Sometimes it is restricted. For example, like this one here. You see this graph goes down, only down to -2, and then it turns and goes the other direction. So all of the y coordinates are bigger than -2. So the range is all y's greater than -2. The other thing that you can look at to start to get a sense of what the graph's going to look like is the degree and the leading coefficient. So if we look at the example in the top right corner, you want to first make sure that your equation is in standard form. So you are writing the terms from the highest exponent, the term with the highest exponent, down to the smallest exponent. And then you're just focusing in on the term that has the highest exponent. That exponent is called the degree. That's our highest degree. And the coefficient is called the leading coefficient. So let's talk about the degree. So we look at that highest exponent. If that degree is an odd number, like ours, then that means that when you're looking at the graph, think of the end behaviors, like where it starts and where it ends when you look at the graph and read it from left to right like you read a sentence. So if you look at the first one here, we're starting from -infinity, you curve, and then you go up to +infinity. So we're starting at -infinity, we're going up to -infinity. Or this one is starting at +infinity, curving, but ultimately going down towards -infinity. So if the degree is odd, that means you're starting from one direction and you're going up to the other direction. Where if that degree, that highest exponent is an even number, that means you're starting, like for this one, reading it left to right, we're starting up at +infinity and then we're ending at +infinity. Or we're starting from -infinity and ending at -infinity. The other thing we're looking at again is called the leading coefficient. So we're looking at that to determine if it is positive or negative. So over here with the odd degree ones, if it is positive, notice that we start at -infinity and go up to +infinity. Start at negative, go up to positive. Where if it is a negative coefficient, we start at +infinity and we go down to negative. Start positive, start up, and then we go down, finish down. Where if you look at the even degree polynomials, if that leading coefficient is positive, we're starting +infinity, ending +infinity. So starting positive, ending positive. Where if it is negative, we are starting at -infinity, ending negative. Starting negative, ending negative.